At the end of the lesson, you are expected to identify a generative model, determine the way of building a generative model, and appreciate the significance of a generative model. In our past lesson, we talked about how to incorporate noise in the model so as to capture the trend the best way possible, and we joyfully learned that having a certain model is not enough because the most thing that could happen to that is it does not tell us what's the real story behind our model. So that is why incorporating the noise in our model is one of the great ways to modeling. However, this kind of process is actually very complex. So let's remember that we always want the simplest. Let me write this. Again, we always want the simplest form if possible. Okay? So, if you still remember our model of our sales performance, so I have it here. So this is the kind of graph that our model, or this is the model that we have. Okay? So, despite the fact that we incorporated the loss function and our ideas of the validation. So we learned about all of these things, how to validate the different data sets and how to understand the loss function in our data. Okay, so we could still say that our model has never been perfect or even near perfect. Okay, so just looking at this one, so we learned that this one actually represents the model that we have. Okay, applying the a certain loss function and identifying the error, then we could have this one. So as you could see, we have different errors, okay, from each data point. So this is because there are a lot of considerations that surround each customer. So for example, this one is each customer, one customer, another one, and then another one. So as you could see, the error for each one is different from the others. Why? Because each customer is different from the others definitely. Okay, so before we continue, hit that subscribe button to enjoy more our deep learning, mastering machine learning algorithm, and natural language processing courses. Click the notification bell to receive more updates. Okay, so let's continue. What we mean here is that one situation is different from the others, right? So this is one customer, this is different customer, this is different customer. That's why one situation is different from the others. So now our concern is it possible to is if it is possible to build a model that is generative. Okay, so now this is our concern. If it's possible to have a certain model that is really generative. And maybe at this point you would like to ask me, Joseph, what do we mean by generative? Okay, so it means that a certain model creates data. Let me write here. So a certain model creates data. So having this kind of model is actually a very good strategy. And why is it? It is a very good strategy because it learns from itself. We don't need to use more time or to exert more effort and even money to find more data because our model creates its own data. So maybe you would like to ask at this point, how can we give or how can we go about generating data from the current model? Okay, so foremost, let's go back to our equation. So still remember this equation? So we had this in our previous lesson. So examining our equation, we understand that if we plug in any values of or any values for w, so we have here the function of x with parameter w. Of course, we learned that parameters could be 1, it could be 2, it could be 3, depending on a certain situation. And of course, we could not just limit a certain parameter to only 1 because there is no hard and fast rule to just identify the exact number of parameters that we're going to use. It would always depend on the kind of situation and data that we have. So it's really very important to, of course, you have to go back to validation, and you have to combine the different models. Which one would really suit to your question, to your business need? Okay. So we know exactly that we generate the value of the sales performance for any certain year. So for example, when we have 2015, this this is just on an example. So we have, for example, this is 10 million US dollars. This is 10M. Okay, 10M. This is US dollars. For 2018, for example, it is 20M. Okay, and for example, our prediction for 2024, it would be 50 million. Okay, just for example, that if we are going to plug in any values for W, we can exactly generate the value of the sales performance for any cost for any certain year. So if we are to follow the performance, it would be like this. Okay, but of course something is wrong with this one. But based on the data that we had before, so it was like this, right? Remember? So uh, this is somewhat confusing and tricky. Uh, if we are going to compare this one to the real life situation that we had, right? So as you could see, so this is the real, I mean, this one is the real, right? So we have here, these points are the real data points, okay? And this one is our model. So if we're going to examine closely, then we can see that it would not exactly form a very straight line because the points are not really in a perfect diagonal line, right? So with this, we can say that the reality and the model do not jive. I mean, when we say jive, it means that they do not really coincide. And in short, they do not paint, or the model does not really paint the real picture. So with this, we need something that is realistic. So this is why we need to add some errors, okay? So that means WT or W transpose X, we're going to add here an error. Okay, for this time, let's just have this kind of equation, but although in our future lessons, we will have more about this one. Okay, so based on this one, okay, so based on this, having the errors in the model is really significant. So it's significant for a number of reasons. And one of the reasons is that the sales performance is different each year. So we had that. So for 2015 is different, for 2016 is different, for 2017 it's different. Okay, so it can be positive sometimes. At other times, it's worse because it can be negative. So it happens, and also it has its own magnitude. So if we're going to go back, see? I mean, okay, this one, the old one. So different magnitude, as you could see, right? So different points. So really very different. So also, we can see that the size or direction of the error and the business do not show bold relationship, as you could see. So with this, we can say that the error is not a function of x, which is the business here in this case. So we are dealing with random variables and random values. So random variables, again, let me say that. So in our study of generative models, we are actually dealing with random variables and random values. Okay, so I strongly suggest you study our previous lesson, since lesson 1, to have a full grasp of this lesson and our future lessons, because we will be talking more about um, probability and statistics. So what is the best way to do then? I believe um, you would like to ask me that now. So the best way to do, or the best way to do, is that we should make a model that can create a random amount of sales performance values. So in short, we need a model that can create certain amount of information. Okay, so these values, okay, let me write that. So, a random amount, a certain random amount. Okay, okay, certain random amount of values. So these values can either be positive or negative, and they can be the same as the errors here. Okay, so most likely if we would like to have, it can be the same. So for example, for this point, the real error is like that. And also if we're going to have our model wherein we're going to incorporate a certain random variable, it must be somewhat like this one. And maybe you would like to ask me, would that be the same for all points in our data? Okay, the answer is not. Okay, because we're going to build something that has a random amount for a certain data point. Okay, so that means for each data point, a corresponding value should be created or generated. So this value must be added to WTX, this one. Okay, WTX plus error, that is for each data point. So having this said, our model can generate its own data. What is this for? Why do we have to study this? With this very meaty introduction on generative models, we will become aware how to make more effective models using this kind of approach. Some examples of generative models are naive-Bayes, hidden Markov model, latent Dirichlet allocation, Boltzmann machine. So as we go through with this part of our course, Mastering Machine Learning Algorithm, we will be learning meaningfully each of them. After all being said and done, let's try this. What is a generative model? Why do we have to learn generative models? Please leave your answers in the comment below so that we would be able to have a very rich interaction of our ideas and we can learn freely and meaningfully from each other. Do you want to know more about this course? Just click the card on your right screen. You can enjoy our deep learning, mastering machine learning algorithm, and natural language processing courses. Learn and upskill for free.